Section 14.6 is about triple integrals. And let's start off by doing an iterated integral. We'll do problem number 4 from the book. Here we're on page 1017. We have the integral from 0 to 9, integral 0 to y over 3, integral 0 to the square root of y squared minus 9x squared, z, d something, d something, d something. Let's see if we can use context clues to figure out what these letters have to be, the x, y, and z. Notice that the bounds here involve both y and x. So that must be z, because the bounds for one variable can depend on the variables which are farther out in the integration, but not the other way around. So the bounds for z are allowed to involve x's and y's. Moving outward one, notice that since my bounds here involve y, this has to be an integral with respect to x. So by process of elimination, the outermost variable is going to be y. Now let's think about what's going to happen before we do it. We're going to integrate with respect to z, and then plug in the two endpoints and subtract. And that's going to give me a function involving x's and y's. I'm then going to integrate that function with respect to x, plug in these endpoints and subtract, and there are only going to be y's in there. And then finally I integrate with respect to y, plug in numbers, and I get a number as my answer. So let's do it. Starting with the innermost integral, the integral of z is 1/2 z squared. I'm going to take that from z equals 0 to z equals the square root of y squared minus 9x squared. I plug in the endpoints and subtract. I can pull the 1/2 to the front. First I'll plug in the square root of y squared minus 9x squared. So when I square that, I get y squared minus 9x squared. Minus, I plug in z equals 0, and that gives me 0. Next, I'm going to integrate with respect to x, treating the y's as constants. So when I integrate y squared, I get y squared x minus the antiderivative of 9x squared with respect to x will be minus 3x cubed. And that's going to be taken from x equals 0 to x equals y over 3. Once again, let's plug in the two endpoints and subtract. So bring down the half that's in front. I'm going to replace each x with y over 3. So I get y squared times y over 3 minus 3 times y over 3 cubed dy. Notice that when I plug in x equals 0, I get 0. Let's simplify in here a bit. This will be half the integral from 0 to 9 of y squared times y over 3 is y cubed over 3 minus 3 times y cubed over 27. Let me simplify in place here. I can cancel the 3 with 27 to get a 9. And then y cubed over 3 minus y cubed over 9. If I get a common denominator of 9, that gives me 2 y cubed over 9. Now let's go ahead and factor out that 2/9. So I'll have a half times 2/9 times the integral from 0 to 9 of y cubed. This gives me 1/9 times y to the 4th, taken from 0 to 9, which is 1/9 of 9 to the 4th minus 0. Oops, mistake here. The antiderivative of y to the 3rd is 1/4 y to the 4th. So I have 1/9 times 1/4 times 9 to the 4th. And then when I cancel a 9 from the top and the bottom, I get 9 cubed over 4, and 9 cubed is 729.